All right, we've got x squared. We've got the x-axis, and we've got x equals 2. So there's our trapped area, and this time we're rotating it around x equals 2. Well, the fact that this is a vertical line, just like the y-axis is a vertical line, means that this is dy. It's always vertical lines are dy, horizontal lines are dx. Because this is dy, we should be looking at x or y values. So I can see the smallest y value quickly, and the other one I got to put a little bit of thought into. So I know this is when x is 2, and I know it's when y equals x squared. So then this point must be a y value of what? Okay, so not a gimme, but definitely enough information to find it there. Now, if I was spinning this around the x-axis, this would be a disk. Oh, well, this one's still going to be a disk because we're rotating it here. So, draw in, well, it's going to be pi r squared. Because this area is hugged up next to the line I'm going to rotate it around, there's no gap in area next to this, so there's no gap in volume, so not a washer, just a disk. So the last real challenge is trying to figure out what the radius length is. Sometimes small circles, sometimes bigger circles, but we have to find some way to describe that radius and then get it in terms of y. How big is the biggest radius going to be? Right, down here, this circle is going to have a radius of 2, right? Does everyone see that? And then it gets a little bit smaller, a little bit smaller, a little bit smaller. So why don't we do 2 minus, and then how much smaller it is this stuff. Well, what is this stuff? Okay, very good. It's this x value to the function, and we can solve this. So it would be 2, but it gets smaller as y gets bigger. So 2 minus wherever that function is at the time. And this guy should give you 8 pi thirds. Yeah.
I'm still kind of confused why we subtract, or why you need 2 minus.
Okay, well, what would the alternative be?
Just square root of y squared.
Okay, so then you're saying that the radius is always the length of, is always the same as y then. Well, what's y here on the x-axis?
0.
Okay, but is the radius 0?
No.
Then this can't be the formula for radius then.
Okay.
That's what I often do, is I usually, especially these harder ones, where you got to do some subtraction, I think of a few different points, I guess in this case. Like when y is 0, I know the radius is supposed to be 2. Like I can see that in my picture. That's a nice round number. So in my formula, if I plug in 0 for y and I don't get 2 for the radius, then I know that this is not set up yet. Like I need to spend more time on it.
Okay.
And then like maybe when y is 4, what is the radius when y is 4? There's no circle to rotate, so this would be 0. So if I plug in 4 for y, do you see how this would go to 0? So sometimes testing a few points will help you know if yours is set up okay or if you need to try to adjust it some more.